Hello, welcome to Nomis Academy. In this video, we are going to be solving problems under Theorem 1. In the previous video, we stated and proved Theorem 1. We said that Theorem 1 states that the line that joins the center of a cycle to the midpoint of a chord is perpendicular to the chord. So we are going to be using that principle to solve problem under cycle theorem. So let's pick the first example. Example 1. A chord is 10 centimeter from the center of a cycle of radius 12 centimeter. Calculate the length of the chord. Alright, to understand the question, we need to make a simple sketch, draw a cycle and interpret the question, and then we go ahead to solve the problem. So let's draw a cycle. We have a cycle like this. Okay, this is the cycle and this is the center of the cycle, and we call the center O. Now the question says a chord is 10 centimeter. A chord is a line that touches 2 points on the circumference of the cycle. So we call here chord AB. Chord AB. Now the chord is 10 centimeter away from the center. So meaning that from here to here, 10 centimeter away from the center of the cycle. Now the radius of the cycle is 12 centimeter. 12 centimeter. That's the radius of the cycle. Now we are asked to calculate the length of the chord. So we have to find the length AB. Now to do that, we are going to be using the idea of Pythagoras. We are going to be using Pythagoras theorem to find the side or the length of the chord. So now let's call this point the midpoint where the line meets on the chord. So let's call that point T. Point T. So using Pythagoras theorem, so it says that AO square is equal to, that is the hypotenuse is AO, is equal to the other side OT square plus, and then the other side is AT square. So we are considering the right angle, the right triangle AOT. Now to find AT, let's slot in the value of AO, which is 12 square, and then the other one OT is 10 square plus AT square. So we are looking for AT. Alright, so 12 square is 144, equal to the other one is 100 plus 80 raised to the power of 2. So let's move this to the other side. It becomes 144 minus 100 equal to 80 square. And then 80 square, we can just flip through. 80 square is equal to 44. Then when we take the square root of both sides, 80 square, taking the square root of both sides, 44. 80 is equal to, you can punch your calculator, then you get 6.63. The square root of 44 is 6.63. Okay, so that's the value of AT, or that's the length of AT. And then remember the principle, or what theory 1 is talking about. It says that the line that joins the center of a cycle to the midpoint of a chord is perpendicular, meaning that it divides the chord into two equal parts. So we can now say that AB from theorem 1 as stated, AB is equal to 2 times AT. Okay, 2 times 8 AC. AT. So AB, which is equal to 2 multiplied by 6.63. So when you do the multiplication, your final answer is 13.26 centimeter. So the length of the chord AB, the length of the chord AB is 13.26 centimeter. All right, let's pick another example to understand it better. Okay, the next question says that example 2, the diameter of a cycle is 30 centimeter and a chord is 12 centimeter from the center. Find the length of the chord. Find the length of the chord. All right, to understand this better, I'll always advise you make a sketch of the statement to get the clear picture of the problem. So now let's take the diagram. We have a cycle, and this is the center of the cycle. We call that O. The diameter of a cycle, so let's draw a diameter. This is the diameter. Okay, the diameter of a cycle is 30 centimeters. So AB, which is the diameter of the cycle, is 30 centimeters. So AB is equal to 30 centimeters. And a chord is 12 centimeters from the center. A chord, a chord, a chord CD is 12 centimeters away. That is, the distance between AB and CD is 12 centimeters. So let's draw a perpendicular line that bisects CD at point T. Okay, at point T. So we can now say that OT is equal to 12 centimeters. Now we are asked to find the length of the chord. So we are looking for CD, which is unknown. So that's what we are to look for. So now we know that OT is 12 centimeters. We need to also know the radius of the cycle. Of course, half the diameter of a cycle is the radius. So if diameter is 30 centimeter, then the radius will be 10 and 15 centimeter. So if the diameter is 30 centimeter, then the radius is 15 centimeter. It means that BT is 15 centimeter. So here is 15 centimeter, while here is 12 centimeter. So we have to find the what? We have to find the height. Sorry, this is not radius. This is not radius. Sorry, we do it like this. This is the radius of the cycle. So here is 15 centimeter. So we now need to look for TD, side TD. So let's clean the other side of the board. So to find TD using or by Pythagoras theorem, we know that side OD square is equal to side OT square plus side TD square. Now OD is 15 square equal to OT is 12 square, and then we are looking for TD square. So 15 square is 255, and then we have 144 plus TD square. To move this the other side, 255 minus 155. Okay, so that will be, okay, sorry, this is not 255 but 225. Sorry, that's a mistake. 225 equal to TD square. So 225 minus 144, that will give us 1. This is 12 minus 4, and that will give us 8. And then here we have 81. So TD is equal to 81. So take the square root of both sides. TD is equal to square root of 81, and that will give us 9 centimeter. So the square root of 81 is 9 centimeter. Now we are to look for CD. Now using the idea of theorem 1, we say that CD is equal to 2 times TD. So that will be 2 times 9, which is equal to 18 centimeters. So the length of the chord CD, is 18 centimeters. Thank you for watching. See you next time. Bye.